We're going to evaluate the integral of the square root of x squared minus 2x plus 17. Now this integral will require trigonometric substitution, but first we have to complete the square. We're going to take x squared minus 2x plus 17 and complete the square. Now x squared minus 2x plus 1 is going to be x minus 1 squared. So that's the key. We're going to take x squared minus 2x. We can add 1, but if we add 1, we have to subtract 1, so the problem is not changed, and then add 17 that was there in the first place. X squared minus 2x plus 1 can now be rewritten as x minus 1 squared, and then minus 1 plus 17 is equal to 16. Now rewrite the integral. The integral now looks like x minus 1 squared plus 16. We're going to make one more substitution. Let y be x minus 1, then dy is just dx. And so the integral in variable y looks like this, the integral of y squared plus 16 dx. And that matches one of the three basic trigonometric substitution type integrals where we have a radical of y squared plus a squared. So matching a squared to 16, we have a is equal to 4 in this problem. Whenever we have the substitution, whenever we have this kind of a radical, the substitution is y equal to a times tangent theta. So in our case, the substitution will be y equal to 4 times tangent theta. Let's square both sides. Y squared is 16 times the tangent squared of theta. Replicate what's inside the radical. Y squared plus 16 is equal to 16 times tangent squared theta plus 16, and that's equal to 16 times tangent squared of theta plus 1, which is 16 times secant squared of theta. We also need to differentiate both sides, so dy is 4 times secant squared theta d theta. Let's plug that back into the integral. The radical had y squared plus 16. It now has 16 times secant squared of theta. And then we had dy, which is 4 secant squared theta d theta. Assuming that the square root of secant squared is secant, this is equal to the integral of 4 secant theta times 4 secant squared theta d theta, which is 16 times the integral of secant cubed theta. Now the integral of secant cubed was derived in an earlier video. You can take a look at that. It was done by integration by parts. In another video, it was also derived by using a reduction formula. It's one of those integrals that you should know well when you're working with trig substitution problems. We have 16. The integral of secant cubed is 1/2 secant theta times tangent theta plus 1/2 times the natural log of absolute value of secant theta plus tangent theta. And so sending in 16, our solution in variable theta is 8 secant theta times tangent theta plus 8 times the natural log of absolute value of secant theta plus tangent theta. But we must leave our answer in terms of variable x. Remember, our substitution was y is equal to 4 times the tangent of theta. So tangent theta is equal to y divided by 4. We draw our triangle to get the rest of the trigonometric functions. So this is theta. Tangent is opposite divided by the adjacent. So opposite is y, adjacent is 4. The missing side is a hypotenuse. By Pythagorean theorem, this has to be square root of y squared plus 16. We can now answer the question in variable y. The solution is 8 times secant theta. Secant is hypotenuse divided by the adjacent. That's the square root of y squared plus 16 divided by 4 times tangent, which is y over 4, plus 8 times the natural log of absolute value of secant, square root of y squared plus 16 divided by 4 plus tangent y divided by 4. We're almost there. We just need to simplify a bit and then replace y with x minus 1. So we have 8 and 16 in the denominator. That's 1/2. Y is x minus 1, so this is x minus 1 times the square root of x minus 1 squared plus 16 plus 8 times natural log absolute value of 1/4 times the square root of x minus 1 squared plus 16 plus 1/4 x minus 1. This is sufficient plus c, or we can further simplify. X minus 1 squared plus 16 under the radical is the original radical, x squared minus 2x plus 17. So we can write the final answer as follows: 1/2 x minus 1 square root x squared minus 2x plus 17 plus 8 times the natural log of absolute value of 1/4 times the square root of x squared minus 2x plus 17 plus 1/4 times x minus 1, and then we can add c at the end.